Hello, I am Dr. P.S. Kannan, Professor of Electrical and Electronics Engineering, Tyagarajar College of Engineering, Madurai, Tamil Nadu, India, presenting the paper published, a novel direct method for generator sharing calculation in EMS of Scada using the Power Division Theorem for minimum loss real-time operation. See the display of figure 1 of a power system having two generators, two transformers, three transmission lines and only one load bus. Ratings of the generators, transformers and impedance of the transmission lines are shown in the display. The load is 50 MVA, 0.8 power factor lagging, operating at 154 kV as shown in the diagram. Decided base MVA 100 and decided base kV 132 in the transmission line circuit. Base impedance calculation is also shown in the figure. The value is 174.24 ohms. The per unit calculation for the generators, transformers and transmission lines are shown in the figure. The load is 50 MVA, 0.8 power factor lagging equal to 40 minus J30 MVA. The corresponding parallel impedance RL and XL is shown in the display and the load impedance is equal to 2.17778 plus J 1.63333. Per unit values of generators, transformers, transmission lines are marked in the figure 1. The per unit diagram with 7 nodes are shown in the figure 2. Calculated per unit values marked in the figure. There are 7 equations to be solved for finding the operating point. The equations are shown in the figure 3. The 7th node is the load bus. Its voltage is already given. The variables are I1, I2, V1, V2, V4, V6. The 6 variables are found by solving the equation with initial guess values. V3 and V5 can be calculated. All the 7 node voltages, generator power S1, S2, currents I1, I2 are given in the figure 2. This is the initial operating point. The initial operating point is shown in the table 1. Voltages of 7 nodes are given in per unit value and converted to actual value by multiplying base kV corresponding to the zone as shown in the table 1. Generator sharing calculation of load and losses are shown in the table 2 in per unit values and actual values by multiplying with the base power 100 MVA. Note that PDT formula is used for finding the sharing of generator on loads and losses as shown in the table. Solving the 7 equations with the 8th constraint equation, generator voltage V1 is equal to generator voltage V2, reduces the losses to the minimum. Table 3 is the solution of 8 equations. Note that the node 1 voltage, that is generator 1 voltage, generator 2 voltage are equal to 1.36455 plus J 0.22059 per unit. After conversion to actual values, these voltages are not equal as shown in the display. The corresponding generator sharing of load and losses calculated by PDT is shown in the table 4. The results are obtained by the common source node voltage operation for minimum loss. Note that the loss is reduced to 1.11225 minus J 12.6516 MVA. The reduction in the loss is 0.46642 minus J 15.97551 MVA, corresponding to 29.55% reduction in active power loss and 41.93% reduction in reactive power loss for the same load of 50 MVA, 0.8 lagging, operating at 154 kV. The general power system is considered in the figure 4. All the real-time actual values coming from the different levels of the entire system at a particular operating point are converted to per unit values in the EMS of Scada. Figure 4 is the per unit system of the power system. The sharing of loads at transmission, sub-transmission, primary and secondary distribution levels can be calculated from the results of the solution of equations with the common source node voltage constraint. Generator 1 voltage V1 is equal to generator 2 voltage V2 equal to generator 3 voltage V3 for minimum loss. The per unit current balance for the entire general power system is shown at the bottom of the figure 4. Each generator share of any load at any level of the entire power system can be calculated immediately using the Power Division Theorem. Similarly, the calculation of share of each generator on primary and secondary load points can be calculated from the real-time data of SCADA. If this novel method of computation is adopted in EMS of SCADA of a power system, faster and best real-time control and operation can be achieved. The approach with Power Division Theorem demonstrates computational simplicity and potential for real-time operational enhancement. It seems that the effectiveness of the fundamental Power Division Theorem in theoretical and practical implementation is increasing day by day. Immediate action is needed to include PDT in the curriculum of universities and institutions. The authors of standard circuit theory books are requested to include the Power Division Theorem in their books for the benefit of staff, students and researchers. Thank you.